Well, my name is MD Ariful Islam. The research project is concurrency control in distributed database systems. The table of content of this paper: introduction, motivation, a formal model for transaction processing, concurrency control, methodology, synchronization technique, conclusion, references, a figure of formal model of transaction processing. Introduction. From research paper, there are two definitions come first. One is distributed database, one is concurrency control. So what is distributed database? A distributed database is a database in which segment of the database is stored on various computers in a network. Distributed database behave as a virtual database that periodically synchronize the distant database. The principal objective of distributed database management system is to control the management of distributed database. Concurrency control. In database management system usually uses concurrency control for multiple user concepts. The concurrency control problem. There are some concurrency control problems such as backup, recovery, response, accuracy, transaction using the same data at the same timing, and so many things. Example of concurrency control anomalies. When more than one transaction is working concurrently, the same target can read information from a database and manipulate other transactions as well. This is called concurrency anomalies. Compared to mutual exclusion problem. The mutual exclusion problem was introduced in 1963, solved by Ijjar W. Dikshotra 1965. And it is hailed as the first issue in the field of concurrency algorithm. The mutual exclusion problem is concerned with I/O device, storage, CPU. The problem of database concurrency control problem is similar to the mutual exclusion problem. Example: if there are two processes trying to update the same bank account, it must take turn, and if each process read the current balance from some database, updated it, and then write it back, one of the updated will be lost for good. Motivation. There are some motivation such as data communication cost and recovery, database recovery, data sharing, distribution and autonomy of business unit, increased reliability and availability, faster response, improved performance, data integration, data coordination, recoverable failed node, parallel transaction. A formal model for transaction processing. Introductory definition and DBMS architecture. Basically, DBMS is able to contain four parts such as TM, DM, transaction, and data. Each four parts that communicate with each other, such as transaction communicate with TM, TM communicate with DM, DM communicate with data. Centralized transaction processing model. Centralized transaction processing model is an advanced infrastructure. It maintains software, associated database, reside as a central site is called treasurer. A centralized DBMS contains two process models at one site, such as TM and DM execute. In DBMS system, a transaction occurs like begin, read, write, and end operation, and by that operation, that operation basically read through TM and DM. TM basically work for TM means transaction manager that monitor all transactions. DM means data manager that monitor all data related transactions. Distributed transaction processing model. A distributed transaction processing model is a database model where it owns four properties: is called acid properties, such as atomicity, consistency, isolation, and durability. What is atomicity? Transactions are regarded as a logical way, that as a unit of process, and it passes all the alarming messages that all proceedings are finished or none of them is harmful. Consistency, accuracy or correctness of a transaction and the transaction of an accurate program that plan one consistent database into another. Isolation is more important part in concurrency control, because isolation has like its ability to, I think is ability to contain deadlock and so many things. And in isolation, each transaction should ensure a consistent database at all the time, and therefore no other transaction can modify or interrupt the information that is being changed by another transaction. On the other hand, I can say if one transaction is worked until is finished, another transaction cannot work. Durability guarantees that once a transaction is committed, the output is permanent and it will never delete from the database, and whatever happened like abort, crash, soon after pulling, it will be committed without modifying or undone. Methodology. In concurrency control, there are two parts, like one is methodology, another is technique. Methodology, serializability and consistency. Serializable provides serial history, which make history to be equivalent. In addition, notion of consistency justify the choosing of serializability, correctness of criteria. Consistency may be considered over a database, but in respect of database, it is not clear that it is consistency or not. Equivalence. To define a serializable history, two equivalent history should be equal and produce same final state for each transaction. In mathematical term, if we see, it look like this this figure, like PH1 equal PH2. Serializability. Serializability is the classical concurrency schema where it can ensure the sequence data transaction, a schedule of transaction to be correct if they are serialized or linear, otherwise they may conflict your information. Theorem of serializability. For validation, serializability theorem is a must need because of it makes the appropriate practical solution for equivalence. In terms of practical compatibility of equivalence, serializability called precedence relation, which is similar to serialization graph. Serializability of logical transaction. A logical transaction might contain number of physical copies of data, and that is stored in the database where all copies of data might at different size. So we can denote like transaction in an order where transaction actually affected in the database system. Synchronization technique. There are some synchronization techniques such as distributed two-phase locking, one-wire, timestamp ordering, distributed optimistic, synchronization transaction within a class, and centralized concurrency control. Now, distributed two-phase locking. Two-phase locking is the basic concurrency control protocol in distributed database management systems, and it guarantees the serializability. Is a correct synchronization when it is played along a cyclic order. The primary aim of this protocol, read in access and write all short. Wound wait is the second algorithm in locking protocol, which moves on the same glide path of two-phase locking. It slightly differs from two-fill, where it must maintain wait for information, then checking for local and global deadlock. Deadlock is prevented using timestamp in this algorithm. Timestamp ordering. Timestamp ordering is a unique identifier that identifies the transaction. Broadly speaking, timestamp values are determined to recognize the transaction which is submitted in the arrangement, so a timestamp can be taught as a particular transaction start time. Distributed optimistic. The optimistic concurrency control protocol is a fourth algorithm in a distributed database. During commit protocol, it causes an operation and the exchange certificate information. In this algorithm, read timestamp and write timestamp are maintained. Synchronization transaction within a class. Class is a phenomenal or blueprint of an object. If any synchronization transaction is executed within a class might be executed in timestamp order and may ensure the serializability. A class pipeline role adequate to guarantee that the transaction within a single class. Centralized concurrency control. Earlier we discussed wait dry and wound wait. On the point are some unnecessary process restart in that step that involve in concurrency control in a given site, where they doesn't know what occurred in the other site, and selecting wait made restart cause of deadlock. Conclusion. Many organizations are building a distributed database for ensuring confidentiality, integrity, dependability, and accessibility of information in all forms. Distributed database is immediately available in the marketplace, but there are a number of matters that need to be worked out satisfactorily. A principal goal of distributed concurrency control is distributed serializability for several database systems. Two-phase locking and other locking protocol is much more cost efficient to prevent the deadlock, serializability, high security transaction, recovery, and also commitment other ordering in the distributed environment. Other treatment is also good for avoiding deadlock entirely, serializability, concurrency control, perform low latency network, and efficient implement of a total ordering, participate atomic commit protocol, global serializability, and so on. There are some references here. Thank you very much. If you have any question, then ask me. Okay, bye.